Hey guys. Right, so Monday we're starting off with a comparison of scientific theory and scientific law. This is a review from sixth grade, so it should sound really familiar. We care about scientific law and scientific theories because most people that aren't scientists get it wrong. Half of the anger and things you see people fighting for in like the news and things is because people, we call them laymen because they don't understand science, not because they're lame, but lay, L-A-Y men, is because they don't understand scientific vocabulary. And this is one of those big things that people don't understand and then they fight and cause arguments about. Big things that we care about is this both column here for scientific law and scientific theory. For one, they are both tested. It's like the most important part here. Both are tested. A theory in layman's terms usually means some idea you randomly pull out of thin air. It is my theory that kids don't get good grades on tests because they're too busy dancing and singing. Do I do any experiments on that? No. Did I ask anybody questions? No. I could say after a survey was sent out to parents asking what kids do instead of their science work, I found out that kids are dancing and singing. We would call that a scientific theory because I did an experiment to figure it out. I tested it. The next part we care is supported by data. Large. To make a theory or a law, you have to have so much data. Lots and lots and lots and lots and lots of data. Not just a teeny tiny little bit that you decide to share. A scientific theory or law does not come up because one random scientist comes up with an idea. It has to be a random scientist and like their 100 best scientist friends. It helps unify a field of study. That means it helps connect a field of study so that other people understand science better. Another idea people have is that laws and theories can't change. That's 100% wrong. It can be modified. The number one way that we modify something in science is by getting better technology. After all, technology and science are besties. That's why Miss Alla and I are besties, and Mr. Brown and I are besties, because science wouldn't exist without technology in order for us to do scientific experimentation. So as we get more technology, we can do more experiments, and then we're going to get new data, which leads us to new hypotheses, which leads us to modified theories and laws. And down here, cuts it off a little bit at the bottom, but widely accepted by a scientific body. That means that most scientists agree with this. It's not some random idea that one scientist decides on. Some of the big things we do want to compare that are different. For a theory, it explains how nature works. How nature works. So we see a lot of this in biology, like the cell theory, because it talks about how nature works. You learned about the cell theory back in sixth grade. A law describes what it does. So remember, a theory is how, and a law is what. And it usually has to be very specific conditions, like laws of gravity, laws of nature, laws of force, because they have to be based on things like here on Earth. It's not just going to be some general like, oh, somewhere in the universe, gravity is 9.8 meters per second squared. It has to be very exact. On Earth, with a general falling volition, we have 9.8 meters per second squared. And most laws get backed up with math. So while I'm besties with Miss Alla and Mr. Brown because we need technology to make science, I'm also besties with most of the math teachers like Mrs. Brown because math backs up science. I can claim all I want, but without some math to back up what I'm saying, no one's going to really care. So you have to have both. So our big difference is that our theory tells us how, our law tells us what, but we mostly care that it's tested, it's supported by lots of people, and it can be modified.